Hi and welcome to Thermo Products training video series on the ABC Setup Rule. As we learned in the ABC Setup Rule introduction video, there are three critical elements that determine furnace performance: airflow, balance, and combustion. Everything starts with airflow. Airflow is the foundation of the entire system. It determines how heat is transferred, how the equipment operates, and ultimately how comfortable the space will be. Even if the furnace is firing correctly, without proper airflow, the system cannot deliver the performance it was designed for. Too little airflow can lead to overheating, high temperature rise, and premature equipment failure. Too much airflow can result in low temperature rise, reduced heat delivery, and potential condensation issues. That's why airflow must be verified, not assumed. In this training, we're going to walk through how to properly set up and confirm airflow using the tools provided. Airflow charts, external static pressure, blower amp draw verification, and temperature rise confirmation. Because before moving on to balance and combustion, airflow must be correct. Now that we understand why airflow is critical, the first step is to determine what the correct airflow should be for the installation. The quickest way to do that is by using the airflow charts provided in the specification sheets for each furnace model. These charts show the relationship between external static pressure and delivered airflow in CFM. Step 1. Identify the correct motor speed for heating. In this example, there are three firing rates: low fire, medium fire, and high fire. Each firing rate has a specific, designed blower speed setting used to ensure proper airflow and system performance. If airflow is wrong, your system performance and diagnostics become unreliable. Step 2. Measuring external static pressure. To use the airflow chart correctly, we must first obtain an accurate external static pressure reading. External static pressure represents the total resistance the blower is working against in the duct system. To measure it correctly, we take two readings. Return side pressure. Measure in the return duct between the filter and furnace. This captures the negative pressure the blower is pulling against. Record the value. Supply side pressure. Measure in the supply plenum just outside the furnace. This captures the positive pressure being delivered into the duct system. Record the value. Total external static pressure. Now combine the two. Return pressure plus supply pressure equals total external static pressure. This is the value used on the airflow chart. Common errors to avoid: measuring in turbulent airflow zones, dirty or missing filters, improper probe placement, not sealing test ports. Accurate measurement is critical. Errors here affect everything that follows. Next, we verify how the blower is responding to the system resistance by verifying the blower performance by measuring the amp draw. Using the external static pressure you just measured, locate the expected motor amp draw on the manufacturer's chart. Now measure actual blower amperage using a clamp meter. Compare actual amp draw to chart value. If amps are high, system resistance is high or airflow is restricted. If amps are low, system resistance is low or airflow is excessive. If amps match, blower is operating as designed. This step confirms the blower is performing correctly under real system load. Step 4. Measure and calculate temperature rise. Temperature rise calculation. Supply air temperature minus return air temperature equals temperature rise. Measure and record supply air temperature in the supply air plenum. Then measure and record the return air temperature upstream of the furnace. Simply deduct the return air temperature from the supply air temperature in order to calculate your temperature rise. Now we want to verify the temperature rise against the temperature chart. Within the gray highlighted area, airflow is correctly set. Closing. At this point, airflow has been fully verified using 4 key steps. Heating fan speed selected. External static pressure. Blower amp draw. Temperature rise. Together, these confirm that the system is operating as designed. Now we can confidently move forward to the next part of the ABC setup rule: balance and combustion.